Hello, DepEd! Welcome to our life!
Are you sad? Are you hurt?
Are you lost?
Are you lonely? Worry no more. You are at the right channel.
Welcome to Excuses!
Hello mga ka-X, let's begin our first lesson for week 4. What's in? Now, remember, geometric sequence is a type of sequence where each term after the first term is obtained by multiplying the preceding term by a non-zero constant called the common ratio. For example, the sequence has the terms 1, 3, 9, 27, 81, 243. And what is the common ratio? Yes, that is 3. What's in? This time, let us determine the common ratio of every sequence given below. For number 1, we have 2, 6, 18, and so on. Now, what is the common ratio for this sequence? The answer is 3. Moving on to number 2. The terms are -4, 8, -16, 32. And the common ratio is -2. This time, let's have number 3. The terms are 200, 100, 50, 25, and so on. The common ratio is 1/2. And lastly, for number 4, we have 3, -12, 48, and so on. Now, what do you think is the common ratio? Yes, that's a -4. Now, this time, I want you to remember this important concepts. If the geometric sequence is in increasing order, your common ratio is positive and a whole number. Now, if you observe that for number 2, the sign in the geometric sequence is in alternate form, then the common ratio is negative. And lastly, if the geometric sequence is in decreasing order, then your common ratio is a fraction. Now that we're done with activity, let's proceed to the discussion part. I hope this will help you better understand geometric sequence and finding its indicated term. What is it? Now, given the first term a sub 1 and the common ratio r of a geometric sequence, the end term of a geometric sequence is found by using this formula. To solve for the a term of this sequence, using this formula, we have to identify first what is given. Now, what is our n? Since we're solving for the a term, our n is 8. What is our first term? Our first term is 60. And for the common ratio, we have to solve for that. The common ratio is dividing the term by its preceding term. So I'll make use of the second term and the first term. 30 divided by 60, and we have 1/2. Now we have the value for the common ratio. Let's proceed with solving for the a term. That is, a sub 8 is equal to our first term 60 times the common ratio 1/2. Our n again is 8 minus 1. Now, let's copy first 60 times 1/2. 8 minus 1 is 7. So, that is, next, copy 60. 1 to the exponent 7 is 1. 2 to the exponent 7 is 128. Next, we multiply 60 and 1. So that is 60, and then copy denominator 128. Now, 60 and 128, this is a proper fraction, but I guess we can simplify it. So what do you think is a common factor? Let's try 4. So you divide both the numerator and denominator by 4. 60 divided by 4 is 15. What is 128 divided by 4? And that is 32. Does 15 and 32 have a common factor? I think not, so this is our final answer. So for number 1, the 8th term of the geometric sequence is 15 over 32. For the second example, we are going to find the 9th term of the geometric sequence, in which the second term is 12 and the 5th term is 3/2. This example is quite complicated, so I want you to listen attentively. Now, the first thing to do is we're going to substitute 12 for the second term and 3/2 for the 5th term in the formula. So, let me start with the solution. Here for our first term, the second term, that would be 12 is equal to, copy first term, r to the exponent. This is 2 minus 1. Or you can simply write 12 equals first term times r. So this will be our first equation. For the 5th term, that would be 3/2 equals the first term times r to the exponent 5 minus 1. Or we can also write this by 3/2 equal to the first term times r to the exponent 4. And this will be the second equation. The next step would be we are going to solve for the first equation, a sub 1. So we will come up with this. And then substitute this expression for a sub 1 in the second equation and solve for r. Here, 12 equals a sub 1 times r is our first equation, and 3/2 equals a sub 1 r to the exponent 4 was our second equation. So from here, how do we come up to this? Now let's proceed with solving. Okay, now we copy 12 equals a sub 1 times r. To isolate a sub 1, we divide both sides by r. So we can actually cancel that, and that results to 12 over r. And that is our first term. So these are just pretty much similar. Now we can substitute that in the second equation. So we have 3/2 equals our first term is 12 over r. So let's substitute the value, and then we copy r to the exponent 4. Next, copy 3/2 equals 12 times r to the exponent 4. Just copy that, and then copy the denominator. And then in this case, we can simplify the variable. So we can subtract 4 by the imaginary 1 here. So that results to 3/2 equals 12 to the exponent, 12 times r cubed. And then if you notice, 3/2 is a fraction. Students find this difficult. If we do have a fraction in the equation, we can actually simplify this by multiplying both sides by 2. So 2 times 3 is 6, divided by 2 is 3, or we can cancel that. So that is 3 equals 12 times 2 is 24. And then you copy r cubed. Okay, now we have to solve for r, so let's divide both sides by 24 to isolate r. And we have r cubed is equal to 3 over 24. Then we simplify this expression by their common factor 3. So 3 divided by 3 becomes 1/8. 1, and then 24 divided by 3 is 8. So we have 1/8 equals r cubed. Then we can extract the cube root. So that would be r. Now, the cube root of 1 is 1. And the cube root of 8 is 2. So therefore, our r is 1/2. Here we can now solve for the first equation, since we already know that the common ratio is 1/2. Now let's substitute it to the first equation. But you can make use also of the second equation. We'll still come up with the same answer. So here, let's copy 12 equals our first term times our r was 1/2. So that is 1/2 a sub 1. Then you copy 12. To solve for the first term, since we have here 1/2, we can actually multiply both sides by 2 to eliminate 1/2 here on the right side. So that becomes 1 times 2 is 2 divided by 2 is 1. We have imaginary 1. Or we can also not write, just copy the variable a sub 1. 2 times 12 is 24. So therefore, our first term is 24. I think on this part, we can now solve for the ninth term, of course, using the formula. So let's identify the parts. Now, the given is for our n, since we are going to solve for the ninth term, so n is 9. Our first term was 24, and our common ratio is 1/2. Okay, so here's our formula. Let's substitute the values. Now, to solve for the ninth term, that is our first term 24, our r is 1/2, and then n is 9 minus 1. That is 24 times 1/2 to the exponent 8. You copy 24. What is 1 to the exponent 8 is 1. What is 2 to the exponent 8? So we have, you multiply 2 8 times. So 2 times 2. And we'll have 256 as our answer. Okay, let's continue. Solving for the ninth term. 24 times 1 is 24 over 256. Now, the fraction here is quite too big. So I guess we can simplify that by dividing 8. So let's try to divide 8 both sides of the equation. I mean both sides, both numerator and the denominator. 24 divided by 8 is 3. 256 divided by 8, we have 32. Do they have common factors? I think not anymore. So there we have it. Our ninth term for the sequence is, geometric sequence is 3 over. So that's it for the first part of week 4 lesson. I hope you find this video helpful.
If you find the lesson confusing, feel free to hit the replay button. Replay! 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 Replay!